Cygnus X-1 is a binary star system located in the Swan constellation of Cygnus, directly due south from the Titan star of Deneb and about 7,200 light-years from Earth. It is composed of a massive, highly luminous blue supergiant star known as HDE 226868 and a smaller, extremely dense and compact object. Thought in all probability to be a black hole, the compact object is estimated to have a mass about 21.2 times the mass of the Sun and orbits the supergiant at a distance of about 0.2 astronomical units. Hi everyone, Vega here, and in today's video we visit the Cygnus constellation, home to the very first discovery of a black hole-like object, Cygnus X-1, for many years known as the Death Star. So let's get to it. The Cygnus X-1 system is the strongest known source of X-rays in our skies. It's created by an intense radiation emitted by an accretion disk surrounding the black hole as it chews away at its giant partner. The black hole has been shown to be too small to be any known kind of normal star or other likely object besides a black hole. The radius of its event horizon is thought to be just 300 kilometers wide. When the object is combined with the powerful winds and gravity of the supergiant, it makes the Cygnus X-1 system an almost unique laboratory for studying a wide range of phenomena and properties of black holes, given its relative closeness and binary nature of the two massive objects. Thought to be about 5 million years old, the compact object, or black hole, likely formed from a gigantic progenitor star that had more than 40 solar masses. It's possible that this progenitor star may have evolved into a Wolf-Rayet star during its lifetime, meaning mind-numbing temperatures above 55,000 Kelvin, while ejecting a substantial proportion of its mass via a powerful stellar wind. Indeed, if Cygnus X-1 had exploded as a supernova, the resulting force would most likely have ejected the supergiant partner directly out of the system. So when you think about it, this does make the story mysterious, and the current theory is that the star may instead have collapsed directly into a black hole with no supernova. At first, astronomers wondered if the object could actually be a neutron star, but we now understand that the largest possible neutron star can only exceed 3 times the mass of the Sun, which left the 20+ solar mass object with little else but to be classed as a black hole, and indeed the first of its kind. Indeed, pulsations with a stable period, similar to those resulting from the spin of a neutron star, have never been seen from Cygnus X-1. So, much is left to discover about this system, and it is unknown whether or not the black hole is spinning. Past analysis of the space-based Chandra X-ray Observatory suggested that it was not rotating at all to any significant degree, whereas completely on the contrary, evidence announced in 2011 suggested that it was actually rotating extremely rapidly, approximately 790 times per second. So at this point it's anybody's guess as to just what on earth is going on in the system, and indeed what happened in the past. As mentioned, Cygnus X-1 is typically the brightest persistent source of hard X-rays in our skies, and not surprisingly much of this is caused by the binary nature of the system. The supergiant for its part is no slouch, and it's a star with a spectral class of 09.71 AB, and it puts it on the borderline between Class O and Class B stars. It has an estimated surface temperature of 31,000 Kelvin, a mass approximately 20 to 40 times the mass of the Sun, and approximately 15 to 17 times the solar radius. These two factors combine to give the supergiant star around 300,000 to as much as 400,000 times the luminosity of the Sun. Indeed, the star is so huge that the black hole is estimated to be orbiting the supergiant at a distance of just twice the radius of the star, or 40 solar radii. What this means is likely that the surface is being tidally distorted by the gravity of the massive black hole companion, fascinatingly forming a teardrop-like shape that is further distorted by rotation. And unsurprisingly, this causes the optical brightness of the star to vary by 0.06 magnitudes during a 5.6-day binary orbit, with the minimum magnitude occurring when the system is aligned with our line of sight. An interesting question scientists are trying to answer about the Cygnus X-1 system, and indeed more in general, is whether or not black hole systems can harbour life. Given the extremely hostile conditions in the vicinity of a black hole, it seems unlikely that any form of life as we know it could survive. However, it is possible that life forms based on different forms of biochemistry, or that have adapted to different environmental conditions, could at least theoretically exist in the Cygnus X-1 system. For example, life forms could exist on planets or moons in the system, while the intense radiation emitted from the accretion disk of the black hole would make it difficult for planets to form and survive in close proximity to the binary system. It is possible that there could be planets or moons farther out in the system that could support life, either created in the initial star-forming accretion disk or perhaps rogue planets that have been captured over time. A planet or moon located at a distance of about 150 astronomical units, or some 5 times the Sun-Neptune distance, from the supergiant could theoretically have conditions similar to those on Earth, including the presence of liquid water and a possibly stable climate. Unfortunately, however, the chances of complex life forming in such a short amount of time, the 5 million years of Cygnus' X-1's lifespan, seem to rule it out, at least for now. In today's final graphic, we see a quiet and tranquil view of the surface of the dwarf planet Pluto. Slowly we see the binary pairing appear, replacing the Sun that is now completely engulfed by and swallowed by the black hole, while the awesome power of the O-class supergiant takes over. Pluto awakens at first to a pleasant warmth that turns into an intolerable hell. Hopefully this gives you some idea of the sheer scale of the system compared to our tiny Sun. From this distance, the supergiant star would shine at approximately -32 apparent magnitudes, something similar to our own Sun at about 6.5 times closer in than indeed our very closest planet Mercury, or just 10 million kilometers. It's more difficult to estimate the lightness of the accretion disk, but this would no doubt also add incredible brightness to the system. Cygnus X-1 has proven itself a unique and fascinating object of study for scientists. The system contains a tiny compacted object with a mass of around 20 suns, in close proximity to a huge supergiant O-class star. The supergiant star is constantly blasting the object with an incredibly powerful solar wind, and hence what would likely be an otherwise quiet and tranquil black hole has accumulated a substantial accretion disk that means it's one of the most prominent X-ray sources in our skies. A mystery remains about the death of the progenitor star, and Cygnus X-1 may have just ripped itself out of existence as quietly as a celestial mouse, but its imprint will remain indefinitely, slowly tearing away at its magnificent blue supergiant neighbour for our inquiring minds to consider. Thanks for watching, and consider subscribing if you haven't already. If you'd like to support the channel further, you could consider buying me a coffee, and I'll link this in the description. Thanks to those of you who already have done so, and if you'd like any videos or subjects brought to life, let me know in the comments below. I can't promise anything, but perhaps next week your idea could show up. Take good care of yourselves and look after your friends and family well, and I'll see you on the next one.